This video is about factoring, and it will help you prepare for factoring any type of polynomial that you see. So let's review a factoring. What's my first step in factoring? I should always find the GCF. So you always want to check, is there a GCF? After you've checked for the GCF, you've got a few options. If there are two terms, you want to know, is it a difference of perfect squares? So a reminder what that looks like. Difference of perfect squares would be something like x squared minus 9. I know this is a perfect square, and I know this is a perfect square. And it's being subtracted, so it's a difference. And that factors as x minus 3, x plus 3. You can do the math to check. X times x is x squared. X times positive 3 is a positive 3x. Negative 3 times x is negative 3x. Negative 3 times 3 is negative 9. The middle two terms are 0, so I'm left with x squared minus 9. So that's how this factors. Okay, if there are three terms, I'm looking to try the AC method. So remember, you multiply A times C, you find the factors that add up to B, and then you factor by grouping from there. If there are four terms, you're looking to see, can you factor by grouping? That means you may need to rearrange some terms to make it work properly, but you're going to try factoring by grouping. Okay, so let's do some examples. Number one, first thing I have to look for is there a GCF? Is there a greatest common factor? Absolutely. In this case, the greatest common factor is a 2a. Since the first term is negative, we usually try to take out a negative. So if I take out a negative 2a, is that all that's in common? Or is there a higher exponent that they all have in common? Yeah, they have an a squared in common. So then I should have 2a cubed left over minus a plus 3. So now I have a trinomial left in here. Can I do a times c on this trinomial? You won't be able to because you have an a cubed in this case. And remember, when we're factoring trinomials, we usually have it in this form. So you just have an a times an you have an x times an x, which gives you x squared. Here I have an x cubed, so it's not going to work. So this is my final answer. I factored out the GCF and I'm done. Moving on, what do I have here? I have two terms. I hope you recognize that. This is one term and this is one term. They're separated by addition or subtraction. So now I'm looking, in these two terms, do I have a greatest common factor? Is there something they both have in common? Yeah, they both have a 5x plus 1. Once I factor out the 5x plus 1, what's left over? I have a 3x squared from this term. From this term, I have a negative 1. So it's 3x squared minus 1. Those are my two binomial factors. Okay, let's try another one. Here, I'm checking, do I have a GCF? Is there a greatest common factor? No, there isn't. I have four terms, 1, 2, 3, 4, so I'm going to try factor by grouping. If I leave the first two together, what do they both have in common? They have an x. What's left over? X minus y. And then what about the second two terms? What do they have in common? So these two have a 5. So you need to make the decision, is it going to be a positive 5? If it is a positive 5, I have a negative x plus y. I want these two to be the same so we can do exactly what we did in number 2. However, they're not. So if that's the case, you've got to try changing this sign. Instead of factoring out a positive 5, try a negative 5. How does that affect inside the parentheses? Well, it becomes a positive x, and it becomes a negative y. Now they're the same. So now I factor out an x minus y. What's left is x minus 5. If something were to happen and you've checked all your signs and it happens to be, oops, the problem looks like this, and no matter what you did, you could not get them to be the same, you could not get this binomial and this binomial to match, then it would be not factorable. But you need to try a few things before you make that assumption. So our problem, number 3, was factorable, and there are the factors. Okay, moving on to number 4. Is there a greatest common factor? No. And I have 3 terms. So 3 terms leads me to the AC method. So I multiply 1 times negative 6, and I get negative 6. And now I'm looking for what are the things that multiply to negative 6 and add up to positive 5. Now I bet you're thinking it's 2 and 3. However, that does not multiply to give you a negative 6. What about 1 and 6? Well, I need it to be a negative 6 when they multiply and a positive 5 when they are added together. So that means it's a negative 1 and a positive 6. Those are my 2 factors. So I rewrite it, x squared plus 6x minus 1x minus 6, or you could write it x squared minus 1x plus 6x minus 6. It's your choice. I'll do both and show you that it doesn't matter. You'll get the same answer. Here, I have an x in common. Left over is x plus 6. With these two, I have a negative 1 in common. What's left over is an x plus 6. So it becomes x plus 6, x minus 1. With this, writing it in the opposite order, these two have an x in common. What's left is an x minus 1. These two have a positive 6 in common, and what's left is an x minus 1. So then I have x plus 6, x minus 1. Same answer. Okay, let's try a more difficult one. Okay, is there a GCF? Yes, the GCF here is 5x. What's left over is an x squared minus 3x plus 2. Now I need to try this trinomial. Can I factor that? So I'm going to multiply 2 times 1. I'm looking strictly inside here. So 1 times 2 equals 2. What are the things that multiply to 2 and add up to negative 3? Would be a negative 2 and a negative 1. So I rewrite it, x squared minus 2x minus 1x plus 2. You could write it the other way. Remember, the order doesn't matter. Now I'm going to still have that 5x out in front. Inside, I'm looking at what do these two have in common? They have an x. Left over is x minus 2. And what do these two have in common? They have a negative 1. And I know I want to take out a negative 1 because I'm thinking ahead. If I multiply negative 1 times a positive x, I get a negative 1x. And I know in my other binomial here, it had to be a positive x. And then negative 1 times negative 2 gives me a positive 2. So now my final answer is 5x, x minus 2, x minus 1. Just like that. The GCF, the greatest common factor, just hangs out. He's just along for the ride out here. Okay? What about number 6? Is there a greatest common factor? Yes. In this case, I'm going to take out a negative 2x. Left over, I have 6x squared plus 13x, minus 13x, plus 6. So now a times c. What are the things that multiply to 36 and add up to negative 13? So I'm going to try 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. So 4 and 9 will add up to 13 if they're both negative. So I have negative 2x, 6x squared minus 4x minus 9x plus 6. Group these two, group these two. The negative 2x is just along for the ride. So now these two have a 2x in common. What's left is 3x minus 2. The second group of 2 has a negative 3 in common. What's left is 3x minus 2. And again, if you took out a positive 3, you would see this is negative 3x and a positive 2, and the signs wouldn't be the same. Your two binomials wouldn't be the same. So you know I got to go back and change the sign. So that becomes a negative 3 times 3x minus 2. Then my final answer, my final answer becomes negative 2x. 3x minus 2 is the common binomial factor, and 2x minus 3. Just like that. Okay, what about this problem? Is there a greatest common factor? Yes, a 3x. What's left? 2x squared plus x plus 1. Now I gotta do a times c. 2 times 1 is 2. What are the things that multiply to 2? Just 1 and 2. Do they add up to positive 1? No, so this trinomial is not factorable. However, my original trinomial was factorable because I took out a greatest common factor. So that's my final answer. If the problem had just said 2x squared plus x plus 1, factor that, my answer would be non-factorable. I couldn't factor that problem. Alright, what about something like this? Is there a GCF? Yes. They both have a 3 in common. Left over is x squared minus 9y squared. This only has 2 terms, so my only option for 2 terms is it a difference of perfect squares? Well, I know it's a difference. Is x squared a perfect square? Yes. Is 9y squared a perfect square? Yes. So I know it factors as 3, something plus, something minus. That's how a difference of perfect squares will always factor. So to get x squared, I have to have x multiplied by x. To get 9y squared, I have to have 3y and 3y. So you're just looking for the square root of each of those features. And I'm done. Alright, last problem. Does this have a greatest common factor? No. Is it a difference of perfect squares? Yes. So, my 2 factors are the square root of 1, which is 1, plus and minus. The square root of 9x squared is 3x and 3x. Does it matter the order? Could I write 1 minus 3x times 1 plus 3x? Absolutely. Multiplication is commutative. Good luck in your factoring adventures.